So first of all, adding and subtracting. So adding and subtracting radicals. If you were doing like terms, like you had x's and all that, you had 3x plus 5x. What you would look at is everything besides the coefficient. If it were the same, 3x plus 5x, you could add those up, and that would be 8x. Okay, so the same idea kind of works with radical exponents. If everything is same besides the number out in front, you can put them together. So if I had 3 square roots of 2 plus 6 square roots of 2, as long as all this is the same, I can put those together. So 3 of those plus 6 of those, that means I have 9 of those. Same way with subtracting. If I had 10 square roots of 3 minus 8 square roots of 3, that means I have 8 of these, or 10 of these minus 8 of these, so that means I have 2 of these. So everything has to be exactly the same. So even if I have cube roots, if I have cube roots, these have to be exactly the same. It has to be the cube root of 7 and the cube root of 7. So I have 7 of these plus 16 of these. That would be 23 of these. So everything, the index and the number underneath, has to be the same for them to be able to be put together. What about this one right here? Square root of, let's say, 6 square root of 15 minus square root of 15. What's the answer to this one?
5 square root of 17.
Right, so there's a 1 out in front of here, so it's like 6 of these minus 1 of these, so I have 5 of these. All right, so if they are not the same, if you have something like 2 square roots of 50 minus 3 square roots of 18, okay, obviously 15 and 18 are not the same, but now that we know how to simplify, we check to see if we can simplify, and once we simplify, they might be the same. They might not, they might be. So here, when I simplify this one, I get what? 2 and 25, 5 and 5. So my pair of 5s break out, and I have 5 times 2 would be 10 on the outside and 2 on the inside. That 2 stays in. And then over here, this would break down to what? 2 and 9, 3 and 3. So 3 comes out, and multiplied times that 3 would be 9. And this 2 stays in, so I have 2. So I have 10 of, now they are exactly the same. They're both the square root of 2, so 10 of these minus 9 of these means I have 1 of these. So if they're not exactly the same, you need to check and make sure to see if they will be exactly the same. So simplify it to see if they will become the same. If you have something like this too, 8x square roots of 5. Okay, you're looking at everything besides the coefficient has to be exactly the same. So I'm looking at everything besides that number out in front. So even that x would have to be the same. So x square roots of 5, I have negative 8 of those, minus 3 of those, so I have negative 11 of those. So everything besides the number has to be exactly the same. If you run across one that is like this, that aren't the same, I can't simplify that. That's the square root of 3 and that's the square root of 7. That's like having 2x plus 5y. I can't break that down anymore, so this would be my answer. That's as far simplified as I would go. Let's go find some tougher ones. All right, so here you have a little bit of a tougher one. But yeah, so what you're going to do is just check to see if you can simplify them. They're obviously not all the same underneath, so let's see if we can simplify. Well, square root of 16 is 4, right? My b's, I have 1, 2, 3. So 1 comes out and 1 stays in. On this one, it becomes, well, square root of 25 is 5. I have b cubed again, so it's the same thing. 1b comes out, 1 stays in. And on this one, square root of 64 is 8. Same thing, b cubed, so 1b comes out and 1b stays in.
Can you say that again? Why it's 2? I thought it was
2 what?
why is it 2 b's? Oh, it takes 2.
Takes 2 to come out, right? This pair comes out and this one stays in. All right, so now if I look, I have b squared to b, b squared to b, b squared to b. So I have 4 plus 5 is 9, minus 8 is 1. So it's b. I have one of these left for my answer. So if they're not the same underneath, you're just going to simplify to see if they become the same at the end. So one like this here. 6 plus 4 square root of y squared plus 8 square root of y squared plus 5. All right, so obviously I can just put 6 and 5 together like we would. They're just numbers, so 6 plus 5 is 11. Here, the square root of y squared becomes what? The y comes out, so that becomes 4y. Same thing here, the y comes out, so that becomes 8y. So now I could put 4y plus 8y together, and I get 11 plus 12y. I'm not going to do that one probably. On this one right here, all right, so on this one right here, this is just a common mistake on the test. I don't know what happens here. So if I divide this by 5, I get, I'm going to divide it by 3 and get 25. 3/4 is 75. So the 5 comes out, and I do 5 times 4. I get 20 square roots of 3. All right, so now I go to the next one. For some reason, I always get this answer right here on the middle one. What's wrong with that? 2 comes out, 7 stays in, but what's wrong with that answer? I got to do 2 times that 2 out front, so that actually is -4. This 2 comes out, there's already a 2 out there, so that's -4. Some people will multiply the first one, then always forget to do that middle one. So now on this one, we got 9 and 3, 3 and 3. So 3 comes out, and I have -18 square roots of 3. So I have 3, 7, and 3, so I can't put that one together, but I can put these 2 together. So 20 of those minus 18 of those means that I have 2 of those. And that would be my answer. Can't simplify any further than that. More. All right, so one with the cube root, still the same idea. Can't put those together because they're obviously not the same. But refresh over simplifying anyway, so we got to break these down. So I can divide that by, I don't know, but I can divide by 2. I can divide 54 by 2. 3, 9, 3, and 3, right? So there I need a group of 3 since it's a cube root. So I need 3 people to break out of jail, so the 3s come out. So I have 15 on the outside. These 2 don't have enough to break out of jail, so I'm just going to multiply them back together and have 4. Like these right here? Yeah, there's not enough. I got to have at least 3 to break out, so there's not at least 3, just multiply them back together. All right, so 256. 16, right? So 4 and 4 and 4 and 4. Now this is one thing that I guess we didn't run into yesterday. Here I could break those down to all 2s, right? But I'm looking for groups of 3 anyway, so there's my group of 3. There's my group of 3, and then here's my one that doesn't break out. So the 4s break out, and then another 4 stays in. So I don't really have to break that down all the way because I have 3. I can just go ahead and pull those out once I have 3 of them. So I have cube root of 4 and cube root of 4, 15 plus 4 of those, so I have 19 of those. All right, so the next part in this section